Okay, so in this video we're going to do two more examples or solving for an equation that has logarithms in it. And so notice this one's a little bit more involved because we have two separate logs on this side. So the first step is always to combine these logarithms in order, I shouldn't say it's the first step, in order to solve this using our one-to-one property we have to combine the logarithms. So the first thing we're going to do is we're going to take this 2 though, we're going to write it as a power. We need to get all the coefficients out of the way. So we've got that taken care of. And now what I'm going to do is I'm going to write or combine this as one single logarithm. So log base b of x squared minus 2, all of that times 6 squared is equal to log base b of 6x. So now that I have logs on the same side, just one log on each side, they're the same log, I can just cancel them out and I can continue working with the problem. 6 squared and then 6x. So I'm going to go ahead and distribute the 6 squared. So 6 squared is 36, so I have 36 x squared minus 72 is equal to 6x. I'm going to move the 6x over, and that's equal to 0. One of the things that I'm recognizing right now too is that each one of these guys can be divided by 6. So if I divide everything by 6, because I'm solving and get rid of it, it makes the problem a lot easier to work with. So now I'm just dealing with these guys, and this is equal to 0. So now we're going to get some practice factoring a quadratic with a leading coefficient. So I'm going to go ahead and multiply both the 6 and the 12, and that gives me negative 72. Two numbers that multiply to negative 72 but add to negative 1. Our middle term is 8 and 9. So I'm going to pair the 9 with the x, doesn't matter which one, with the x squared, and I'm going to put the 8x with the 12. And we're going to factor by grouping. So I split the middle, and then I look at the greatest common factor. So if I pull out the GCF here, that's going to be a 3x. That's going to leave me with 2x. Let me erase that so I can clean it up. That's going to be 2x minus 3. Greatest common factor, I want to pull out a 4, and the way that this one works out is we're left with 2 pieces of our, that's a minus 3. I'll go ahead and move this up a little bit. I'll move it over so it's out of the way. Okay. And so now I know that my solutions are x is equal to, and this is supposed to be a 4, x is equal to negative 4/3, or x is equal to 3/2. And remember, with these problems, we have to do a check. We can't get a log of a negative number. So I'm just going to use the side that's easier to work with. I'm going to use this side. If I plug in the negative 4/3, log base b of negative 4/3, well, this is going to be negative. I cannot have a negative value, so I throw that solution out. The 3/2 is my only solution. Okay. Now we're going to go ahead and move on to our next, or this problem right here. There's varying ways that we can solve problems, but once again, the idea is, you're trying to get rid of those logarithms and you're just solving for x. It might be a simple equation that we're solving, or it might be a quadratic. Once again, just solving. So we got to apply those properties, and so just look out for like the one-to-one. We can't have the coefficients. If I have 2 logs on either side and the same base, they're equal to each other. So you got to make sure you look out for those specifics. Now this one, a little bit different. A couple things that we can do here. I can rewrite this as a logarithm, or it's in log form. I can actually just convert this guy to exponential form. It's a different way to do it. So I could look at it as, hey, a to the 0 is equal to 6x minus 2 all over 5x plus 7. Well, that's just equal to 1, and now I can cross multiply. So I have 6x minus 2 is equal to 5x plus 7. And I'm going to solve. I'm going to subtract the 5x, so I get x is equal to 9. And that'll work for both of those. Another way to do this is I could split the logarithm because it's division. That means I can expand and create a subtraction problem. If I move that guy over, I have log base a of 6 minus 2 is equal to log base a of 5x plus 7. Because the bases are the same, I can cancel them out, and I get 6x minus 2 is equal to 5x plus 7, and we're back at that same spot that we were the different way that I solved the problem. So those are two more examples of solving equations with logarithms. Keep in mind that, whether it's this problem that we're doing here,